Alright, now let's go ahead and take a look at question number 3 on how to integrate using the U substitution method. So let's say we want to evaluate the integral sine of 2t divided by 1 minus cosine 2t dt. Alright, to get us started, let's go ahead and refresh our memory on what the um, formula is for integration using U substitution. Okay, so the formula for integration using U substitution is as follows: the integral of f of g of x times g prime of x. We went over this in numbers 1 and 2, so this is just a refresher for you, is equal to the integral of f of u du. Just remember that U substitution enables you to express complicated integrals in a much elegant and easy to integrate fashion. Alright, let's go ahead and do it here. So first things first, what we're going to start off with is rewriting the problem in a way where it's easy for us to identify what the composite function is and the derivative of the inner function. Okay, so we executed these exact steps in problems 1 and 2. We're going to do it again here. So what we're going to do is separate it. Let's write the composite function first in harmony with the formula that we have here. Alright, so the composite function, which is a composition of a rational function, a linear function, and a trigonometric function, is 1 over 1 minus cosine 2t, and then times the other function, which is the derivative of g of x, okay, the derivative of the inner function. So we have sine 2t dt. Alright, so let's go ahead and identify what our u is first. So our u for U substitution is the biggest innermost function that results in sine 2t or its multiple upon differentiation. Okay, so I could have selected cosine 2t, but there's a 1 there that if I add it on and differentiate, I will still get exactly the same result. So the bigger the function, the better, the easier the substitution is. You want to substitute as much as possible so it looks elegant. Okay, so if that is our u, we're going to say u is 1 minus cosine 2t. So we're going to differentiate both sides with respect to t. So du dt is equal to the derivative of 1 is 0. The derivative of cosine is negative sine. So if you multiply that with this negative right here, it becomes positive. So it's going to be positive sine. Derivative of the outer evaluated at the inner, chain rule, times the derivative of the inner. The derivative of the inner function is 2t prime, which is 2. Okay, so there you have it right there. So that's du dt, so multiply both sides by dt, so that's du is equal to 2 sine 2t dt. So the question now is, do we have a clean substitution? Take a look at what we have here, sine 2t dt, which we want to substitute also, and over here we have 2 sine 2t dt. Do we have a match? The answer is no, we do not have a match. Sometimes we have a match, sometimes we don't. In this particular case, we do not have a match, so we have to carry out some arithmetic operations to make sure that they match. Okay, so what are we going to do? We need to address this coefficient here, since this derivative of u doesn't have a coefficient, derivative of g. So what we're going to do is divide both sides by 2 to fix that problem. Divide by 2. So we now have du over 2 is equal to sine 2t dt. Ladies and gentlemen, we have a perfect match. Check this out. Sine 2t dt, this matches perfectly with what we have on right here, sine 2t dt, and that tells us that this is du over 2. Okay, now let's go ahead and make our U substitution. When we carry out our U substitution, we're going to have this complicated integral is now going to become the integral of 1 over u for this portion, and then the derivative of g prime. G prime is going to be du over 2. Okay, let's make it look pretty. Factor out that divided by 2 or multiply by 1/2. Factor that out. So we have the integral of 1 over u du. Do you see the power of the U substitution method? This complicated integral right here has completely been simplified into this elegant looking integral, which is very easy to integrate. So the antiderivative of 1 over u is the natural logarithm of u. So this becomes 1/2 of the natural logarithm of the absolute value of u plus c. Are we done? The answer is no. We carried out our substitution step here, and guess what we do after you integrate? You have to resub. Alright, you resubstitute what you substituted out. So if we carry out our resubstitution, the answer that we got, 1/2 times the natural logarithm of the absolute value of u plus c. We'll take that u out and replace it with what it originally was, which is 1 minus cosine 2t. Your answer will be 1/2 times the natural logarithm of the absolute value of 1 minus cosine 2t plus c. Alright, ladies and gentlemen, that is our final answer. Let's just write it again. Final answer for the problem is 1 minus cosine 2t 1 minus cosine 2t absolute value natural logarithm. Alright, so there goes the final answer for question number 3 on how to use the U substitution to carry out the integration process. Alright, we have a question for you on this problem. There's a common mistake that most students make when integrating this particular integral. They try to use the power rule technique. They rewrite this as the integral of u to the negative 1, and they try to use the power rule, and it ends up being undefined. So the question is, did you think of using the power rule to integrate this, or were you able to remember that the integral of 1 over u is ln absolute value of u? If you remember to do it, or if you forgot, just let us know in the comment section below so we can see how good you were at evaluating this special integral 1 over u.